Everyone hear me okay? Perfect. So my name is Christer Tärning. I will not talk about AI today. For once, I will talk about Iceberg and the Lakehouse. This is future stuff. So, disclaimer, anything I say might change. And for that reason, please, no photos on social media as well. But we're going to talk about Iceberg. But first, I want to start with the Lakehouse, which is the end product, you could say. I'm going to cover what, why, and how. I will talk more about the Qlik Open Lakehouse that Joanna showed this morning, because that was a very brief demo. And I will also talk a little bit about the impact that you might see. So where is the Lakehouse coming from? Well, I've been around for a while. I was around before you had the data warehouses, actually. But data warehouses were a thing, you could say, in after year 2000. They started to build these. And they were good. They took away the pressure from the operative systems. You integrated data. You might got some historical layers on top of that. And you got typically some semantic layers with analytics-ready data. But they were SQL-based. And nowadays, SQL is not really good enough. So for like 15 years ago, 10 years ago, we started to see the emergence of the data lake. I think you've been there, all of you, most of you at least, building a data lake. It had fantastic promises, but, well, it didn't really work out. I mean, you can run your Spark, your AI workloads here, but it was a little bit swampy. There was not much governance. So this is what the Lakehouse promises, more or less. You should be able to run all your workloads, and it should be governed. So how does it look in many places today? Well, first of all, most enterprises, most companies that I know of, they pick the data platform first. And that could be, well, the platform that suits you the best. Then they pick like the integration tools to feed it, to ingest it, and they pick BI tools, analytics tools, and so on. And yeah, on theory, this is a pretty good thing to do, I would say. But what I see when I talk with customers, it's like Nirvana didn't reach you. There are some pain points. Because in many cases, why we had the data warehouse, we had a data lake, you have several data platforms. You have one for SQL, another one for Spark, typically. And it's very costly to ingest data. Typically, it should be the same data that you're ingesting to both platforms. Doesn't need to be the case, but it's expensive to ingest it to different platforms, and then maybe you need to do the synchronization between them across the platforms. You have quality issues in both places. Another thing is that in these platforms, you have combined compute and storage. And this is more or less some sort of vendor lock-in, which is what the future, you could say, is promising, is not to have this lock-in. You will have a separate compute and a storage. And all of this is even more accentuated when we're talking about low latency, because low latency means that you're updating data all the time. And actually, we have customers that they even have a third data platform. So, I mean, this is really a nice picture in that sense. So, what we want you to do is not to pick the data platform first. We want you to center around your data. And the Open Lakehouse is the way to do that. And you could say more or less the definition of it would be that you will get one single copy of data to streamline all of the integration, your quality work, the governance work. It should be then interoperable with different engines, allowing the flexibility you need. Sometimes you want to run SQL, sometimes you want to run Spark, sometimes you want to run something else. And on top of that, it's getting more and more important to look and the security, because this gives you an opportunity to process the data in your environment. And that is a little bit what you can get when you use Iceberg. So how does it look in the market? Well, this is a survey from Dremio last year, and it really more or less just says that Lakehouse adoption is really taking off. And this is Lakehouse in general. It's not only Iceberg. I will come back to that. And the reason is really that it's about cost savings, because this platform is well, it will save money for your maintenance and your operations of your data platform. And if you look at the major players, the hyperscalers and so on, I mean, there are some level of support from all of the major platforms. Google are there, AWS, Microsoft, we have Snowflake. I mean, we have even Databricks, which are really pushing the data lake, which is another provider of Lakehouse in that sense. They bought Tabular for a big number. And Tabular, if you don't know that, that is the founders of the Iceberg specification. So that's really a heavy bet, you could say. And we are there as well. We acquired Absolver to get ahead, you could say, in this area. And we are really, well, pushing ahead. We are delivering this very soon. I will not do any promises like Dan promised. The idea is that you will see this month, but no guarantees. No guarantees. So, all you need is Iceberg? Well, sorry. Iceberg, it is just a specification. It's a paper, nothing else. It promises a lot of capabilities, like ACID transactions, I guess, is the most prominent one, but schema evolution, partition evolution, time travel, stuff like that. But again, it's not kind of magic, it is a spec. And it needs to be implemented. And it's up to each engine that implements it how it's done. And I will come back to this because this is very important part. In my mind, it's about the maintenance part of it. It sounds very boring, and for some people it is. And when it works, well, it just works, should work. It's maintenance. But maintenance is crucial for performance when it comes to Iceberg. And then again, it also needs to have some integration with catalogs to allow all of these different engines to access it. And we at Qlik, we love low latency as well. And all of this is accentuated when you have low latency. So, what is it then? What is it? So, I'm going to try to do some layers to show you where it fits in an architecture. So, in the bottle, you have the storage layer with your hyperscalers, where you put your medallion storage, the bronze, the silver, the gold, and you store that in some sort of files, typically Parquet files, could be awk, Avro, or typical open file formats that you would use in a lakehouse. And all of these has been around for quite some time. But the next step, it is, in my mind, it is only metadata files, what Iceberg really is, as more or less Data Lake and Apache Hudi, which are the other two solutions you could work in this space. The Data Lake has, as you know, I said, been pushed by Databricks. It works, no big deal about that. It works a little bit differently, but it works. But it's like only Databricks that supports this. Hudi, it's Apache Hudi. It's a well, open source thing. I haven't seen it in any enterprise from that perspective. So we are betting at Iceberg, and it looks like all of the major platforms are betting on Iceberg as well. And then on top of that, you have the catalogs. You have Polaris, you have Glue, Hive, Nessie, and whatever they are called. There are a bunch out there. And they are using what the metadata inside of the open table format provides to be able to query it with any engine of your choice. This is just a subset. So, this is an extract from Iceberg. It says what kind of files that could be in there. I will not go into the details, but this is directly from the Iceberg spec. More or less, it says that there are a bunch of metadata files that keep track of the data. Manifest files, snapshot files, are, well, understanding what's inside the data. And all of this is about keeping that metadata up to date. And for that matter, also keep the data files up to date. That's when I'm going to talk about maintenance. So, what is it? It is an open table format for instance, for S3, for instance, could it be? It provides high-performance queries over batch and streaming from an engine. It gives you ACID transaction, data optimization, retention, time travel, stuff like that. Some use cases is cost-effective ingestion for batch streaming data, your data. Cost-effective data prep, quality. You can use any specialty engine, understanding Iceberg, of course. And it has a secure marketplace with data sharing and so on. So the key benefits are, it's simple, it's no lock-in, it will give you single source format for all kind of workloads. And there are already a big ecosystem of tools out there. So we are introducing the Qlik Open Lakehouse. It provides, there are three main components. We have the high throughput ingestion, which you can have like access to like all operational systems, more or less every database, and a bunch of other sources as well, straight into Iceberg. We have the central component here, the adaptive Iceberg optimizer. I will come back to that in a minute. And we also have the mirroring, because as I've explained, Iceberg is really a bunch of files, data files, metadata files. And you can really call that your bronze layer. You can access them directly from compliant tools like Athena, SageMaker, and so on. You don't need to do anything else. But if you want to do something in, let's say, Snowflake, or any other data warehouse, then it needs to understand what it is, and you need to instantiate some objects, some external tables. It's not any copy, it's just a mirror. So no data duplication, just a mirror that you could, then let Snowflake or any other platform or compute process the data downstreams or with any other tool you want to use. Let's look at the architecture a little bit, how it's implemented. So on the left side, you have your data sources. On the top, you have the Qlik Talend Cloud. It's the same Qlik Talend Cloud that you have today, if you have it, I hope. So Qlik Talend Cloud, and I should say as well, this is not any new product from us. This is a new capability inside of Qlik Talend Cloud. It's available for anyone with standard package and app. So it's going to be there when it's GA. So the Qlik Talend Cloud, that's where you design your pipeline. That's where you control the pipeline, and that's it. The ingestion is going to be done by the Qlik Data Gateway, which is a very battle-proven technology we have that are, getting the data from your systems and ingesting it into the cloud storage. It's, if anyone here has heard of Qlik Replicate, it's actually the Qlik Replicate engine, more or less, running with some additional features. And in this case, it's going to put it in Iceberg tables. So, to maintain this, we have the clusters that Joanna talked about and showed. These are actually the core of the Absolver technology that we acquired. So these clusters has been running at Absolver customers for 4 or 5 years without any issues in big scale, petabyte scale. So they work very well. And they are responsible for maintaining the Iceberg table. And this is, they are running, for instance, the Iceberg Adaptive Optimizer. They are doing, automating the pipelines. They are running in your environment, so it's your cost, but they are also using easy-to-spot instances, the cheapest ones available, So they are like the cheapest way to do any compute. And then you could say, oh, wow, maybe AWS is going to pull an instance from me. Yeah, sure. That's happening all the time. It's built in. It's very resilient. It's like what you say, idempotent. So they just keep on working. They understand this. They are auto-healing, auto-scaling. So it's like you set them up, you fire, and you forget. They just keep on working. And it's with them, they also are responsible for the updating the catalogs. So, well, not updating the catalogs, but make sure that it's integrated and synchronized. And then, if you want to do some downstream processing of any kind, maybe you want to use some other pipeline to do further transformations. Maybe you just want to ask something inside of Snowflake. Then you mirror data. Again, no copy. It's just a mirror. And then you can do whatever transformation you want downstream. It could be creating your silver layer and your gold layer, but it's up to you. Yeah, a few words of the clusters. I think Joanna showed the right part of this. So the only thing really you need to think about is what scaling strategy you want to have. Should it be low cost? That could be for a development environment. It should really be the lowest cost possible. Or is it really business critical stuff? Then maybe you should pick the consistent low latency, or the low latency is a little bit in between for I would say production workloads that are not that business critical. And you set these when you create the instance, and fire forget, they just work. And again, this has been proven for a long time in actual existing customers. So, adaptive optimizing. A lot of fuss about that, and this is actually something that sounds very easy, but when we're talking about low latency, when there is real-time ingestion, every minute there is a change from some transaction system, there's going to be a big number of files, because this is really some sort of data lake. So there's going to be a number of small files on that data lake, and then we have the lakehouse, our engine, the cluster that maintains this to make it efficient. And it could be for different reasons. I mean, first of all, each change is coming as a new small file, and that's going to be a lot of small files. And there's going to be snapshots to be able to do this time travel. So there's going to be a lot of snapshot files, and you can set, there are built-in specifications, so I can do this, but we are making this automatic for you. Another thing is that the spec says optimistic concurrency for transactions, which means that if you have a transaction with 100 changes, 99 of them are working, but the 100th is failing, the transaction will be aborted, and there will be 99 files on disk, orphaned. So you need to clean this up as well. And this is by design. It happens all the time. So, yeah, I've talked a little bit about file compaction. This is the operation where we are picking up the smallest files and merging them into larger files. This is something you could say you can do manually, of course, if you have low latency. Low volumes. But if you have high volumes, this is going to be a very expensive task. I mean, file operations in general are very expensive. And I mean, even have a name. It's file access overhead from the data lakes of the past. So we are doing this in an intelligent way. We are looking at the benefits. We are doing a cost evaluation of each compactation and doing a prioritization, and always picking the one that are the most benefit. And when that's done, we're picking up the next one, and so on. Yeah, we were a little bit late. I'm going to try to speed up. Snapshots, the same story more or less. We automate it for you. They are created by design, but we automate the expiration of them. Orphaned files, same thing. Could be a number of reasons, but we are doing that again, automated. So the adapted Iceberg optimizer. That is a little bit of the Qlik thing. It has, as I said, cost-based compaction, intelligent cleanups, and all that. Also responsible for automatic scaling and healing. Yeah, coming from Upsolver, and yeah, small benchmark. So we tried 3 different ways. It's the same data, Oracle data, ingested for 2 hours, 140 million rows, 60 gig of data. 3 types of table, one without optimization, one with another leading optimizer, and then a third with our optimizer. And of course, we are really proud of this result, but first of all, you could see if you don't have an optimization, I mean, the numbers are way off. You're going to have problems. So this has really, optimization is a must. You need to have that. But again, the second choice is a leading other vendor, and we are doing like 30% better in average. So we are really proud of this optimization task that we have. As I said, it's battle-proof. This is some of Upsolver's existing customers. I will not go through them in detail, but let's say Unity, they replaced the Redshift warehouse completely with this. They save 1 million a year. Cox Automotive, it has a very specific use case. It's all about security, but they replace Splunk, and again, saving 1 million a year. So it's battle-proof. You could say that. It's really working really good. So I'm getting close, ending up a little bit. So sit tight a little while. The survey said that it's all about cost savings, and absolutely, you will get cost savings, just matter how big they are. But I would say the increased agility is as important, because you will be able to very likely get rid of a number of tools that are using some other platforms and so on, and you will be able to just get a new solution into place to analyze the same copy of data. So it's not going to be any new copy, because they're going to read that Iceberg metadata with the single source of truth. So some questions: are you looking for more flexibility, lower latency, or reduced cost? Yes, of course you are. Are you loading data to multiple data engines today? Well, then you have a very compelling business case to do this. And finally, are you looking to optimize your data warehouse spend and compute? Yeah, of course you are. So I take my advice would be you take a look at the Lakehouse, and especially the Qlik Open Lakehouse, because it's going to be very performant. And we are saying that you will reduce cost with 50% at least. You also have the ingestion possibility with low latency, real-time access, and then you have the query performance. I haven't really talked about query performance a lot, but with this setup, with the optimizer, you will get a lot faster queries as well. So I hope you learned something a little about Lakehouse, Iceberg. That's it for me. Take the chance to have a Volvo for a weekend, and I thank you very much.